Hello all, welcome to our project rain prediction using machine learning techniques and auto machine learning techniques like PyCaret. This is an end-to-end deployment project, which means we will be building a complete machine learning app with the help of the data given. So now main aim of this project is to detect whether it will rain or not in the next day with the help of using the weather details which we have. So now what is the motivation behind this project? So imagine you have to plan, or it happens somehow that you have to plan a picnic with your friends and it rains the next day. So how bad it will feel, right? It will be very disheartening. So what if we could predict it? Okay, what if we could predict whether it will rain or not? It will be a way, it would be very beneficial and wonderful for us, right? So what we will do, we'll be doing building a machine learning app which will be predicting us that okay, it will rain or not, so that we can plan our journey for the next days ahead. So now this is the main methodology that we will try to build a machine learning model with the help of different ML and auto ML techniques to predict whether it will rain or not. Also, as I said, this is a complete end-to-end project, so we will deploy our model using the Flask API and the Heroku platform. We have a data which have different attributes which will help us in predicting the outcome. Okay, I will give you the data. We'll see and explore it in the next sections. So now let us discuss about the auto machine learning library which we will be using. So we will be using PyCaret. PyCaret is an open source low code machine learning library in Python that allows you to go from preparing your data to deploying your model within minutes in your choice of notebook environment. As a PyCaret is a very popular library, and PyCaret has numerous amounts of library algorithms. Right? It runs on the scikit-learn library. It has very all the sklearn modules, all the classification regression modules. There are certain advantages by PyCaret is preferred. That is, it increases productivity. It is very easy to use. It is business ready and many more. So this is the basic platform we'll be using for our model deployment. First is the Flask API. RESTful API is an extension for Flask that adds support for quickly building REST APIs. Basically what this will do, this will create, or this will link our model with the outer world. Okay, this will create an API so that we can deploy our model. Then we can deploy our model with some platform, right? We need a platform to deploy our model, and that platform is Heroku. Heroku is a cloud platform as a service supporting several programming languages, and this was the first Heroku was developed in was oh sorry the first cloud platform Heroku has been in development since June 2007. Okay, so these are the services which we will be using for our deployment. So now this is the timeline of our project. First we'll be doing the data analysis, then feature engineering. We'll be seeing what all different features are important. Then we'll build our model using machine learning technique. Then we'll use auto machine learning. Then we'll finally deploy our model. Okay, so let's begin. Hello all. So now let's start our project, the rain prediction using machine learning models and our auto machine learning library, PyCaret. So in this project, as you can see, we will create a web app which will predict whether it will rain tomorrow or not. This is a very interesting project in that we'll be doing a lot of feature engineering part, and we'll be doing many of the machine learning and model building part. Then we'll deploy a model. You'll come to know about the Flask API and Heroku platform and all the technology and machine and the methods behind it. So first, let us see that what is the timeline of the project, right? So the timeline of the project, first we'll be doing the data analysis part, then we'll be doing all the feature engineering part. Basically we'll handle the missing values, we'll handle all the categorical variables. In missing values, we'll do some random sample imputation, we'll do some mean median mode sample imputation. Okay, so handle the missing values. There are different techniques to handle missing values. Then in handling categorical variables, we'll be doing one hot encoding, we'll be doing label encoding depending on the data. That all comes under the feature engineering part, right? Then after prepare, then feature engineering will scale our data. Then after completing our data, after making our data complete to feed our model, we'll be building different machine learning algorithms. We'll be using different models. Then we'll be checking the accuracy. Okay, which model is performing better. Then we'll be building auto machine learning. We'll be using auto machine learning, that is the PyCaret library. I'll be showing you what PyCaret is, how you can deploy your model using PyCaret, what all the libraries are present. I'll be showing you the official PyCaret website. Okay, now the last thing which is not mentioned here is the deployment part. Okay, so we'll be deploying our model. I'll be doing that in an IDE. I'll be explaining you why I'll be doing that. I'll be doing that in IDE for the things required in it. So with the very first thing, let us import our libraries. We'll be importing pandas, numpy, seaborn, matplotlib. These are for data analysis, feature engineering part. Then we'll be importing train, test, split, to for splitting our data. Then a metrics part for accuracy, checking that how much our model is performed, accuracy score, confusion metrics. And then matplotlib inline, just a magic line which makes sure that the plots which we make are remain in this notebook only, are showed in this notebook only. Okay, so now this is a Google Colab environment, there is a certain different procedure to import our data. The very first thing what you have to do is you have to import your file in your Google Drive. Okay, the CSV file which you want to read, any of the file, okay, any of the file which you want it to read. So for you have to import that file in your Google, in your data, okay, in your Google Drive. Then what you have to do, you have to mount your drive in your Google Colab environment. So for that you just have to click on this button. This is the mount drive. When you will click this tab will open. Okay, this command will open. You just have to execute it. When you will execute it, okay, so now I have already executed it. That's why it is saying mounted at content drive. Okay, when you will not, if you are doing it for the first time, what it will do, when you will execute it, it will give you a link. Okay, if you click on that link, it will take you to your all the account information. Okay, you just have to give the permission of to for the Google Colab to access that account drive. Then it will give you a link. You copy that link and paste it here. There will be a account box here. You just have to paste it here and press enter. Then it will be showing that you're mounted at content.drive. Now when we'll see here where drive is mounted, so see, this is my drive, and when I'll click on my drive, so these are all the different files which are present in my drive. So I have already uploaded my CSV file in my drive. I'll find it somewhere here. Okay, my file is name is weather aus. Okay, I'll just copy the path of this file. I'll just copy the path and I'll read my file with this. Okay, I'll paste the path here and I'll just read my file. Okay, so now I have written a command pd.set options display max column. Why I have written? Okay, when if I don't do this, okay, now when I see my data, as you can see, this is a very large data set. Okay, 1,45,000 rows. Okay, 23 columns, but 23 columns is there. But when if I'll not do this, okay, I've already done it, that's why it is showing all my columns. But if I don't do this command, okay, if I'll not run this command, what it will do, my all the columns will not display. Okay, some of the columns will get skipped because of the space. That's why I'm using display max columns. Okay, so now it is displaying me all of my different columns. As you can see, it has 23 columns. Okay, the date, location, minimum temperature, maximum temperature, and all the different things. Okay, and the lastly my dependent variable rain tomorrow. This is my dependent variable, this I have to predict. Okay, so now this was a brief look on our data. Okay, you can have a look at this data, understand it. These are the different informations, all the different information which will help us predict our data. So in this was a brief introduction on how to read your data and how to import your data file. Okay, in the next section we'll be doing the data analysis and all the further proceedings in the next section, in the next videos. Hello all, welcome to our next section of the project. That is, in this section we'll be doing the data analysis and we'll be handling the missing values, right? What are the different missing values in our data? So first of all, we already had a look at our data. Let us have a look at data again. This is our data which has around 1,45,000 1,45,460 rows and 23 columns. As you can see, this is a very large data set. Okay, so now this will be this has many as this is a large data set, so that it will be containing many number of null values. Okay, so let's, the first thing we will do, that we'll see that what are the unique values in all the variables. As you can see, date has this much unique values, location has this much, 49 different location, different maximum temperature, there are 16 different directions of wind directions, Okay, 16 different directions, then they are different clouds category, and then there will be, if there will be rain today, rain tomorrow. Okay, these are the different unique values which each variable have. So now what we will do, that first, the very first thing which will help us in doing our data analysis part is, let us categorize our data into different things. Okay, the first thing we will do is we'll categorize the data into numerical variable. Okay, so what we will do, I'll write a command, create a list in that feature, for feature in df.columns, if feature data type not equal to object. Okay, so what it will do, it will give all those features in which the data type is not equal to object, that is my numerical variable. But now what happens is, in numerical variable there are two types, one is the discrete variable and one is the continuous variable. The discrete variable is that in which whose category, whose the number are not large in number. Okay, there are many not different number of categories, they are not continuous. Okay, discrete variables, which means there can be the different number of categories like 1 to 25. Okay, that is why I have written feature for feature in numerical variable if length of the unique features are less than 25. Okay, the unique feature are not more, less than 25, these are a discrete feature. Then the continuous variable will be those which are not in discrete feature. Okay, the variables features which are not in numerical variables, which are not in numerical, sorry, which are not in discrete variables in the numerical feature. Okay, the which means that basically they will be my maximum temperature, minimum temperature, rainfall, evaporation, these are my continuous variables. Okay, right. Then the last comes is our categorical variables. Okay, the all the features which are not in a numerical variables are categorical variables. So we'll just execute it, then we can see, okay, what all the, if I want to see my categorical variables. Okay, so see, these are my categorical variables: location, direction, wind direction, and if there will be rain today or tomorrow. If I want to see my what, if I want to see my continuous variable. Okay, so I'll just see my continuous variable. These are all my continuous variable. As you can see, there are many number of null values in these. The my maximum temperature, minimum temperature, rainfall, wind speed, these are all my continuous variable. Now if I want to see what all are my discrete variables, I'll just see what all are my discrete variables. As you can see, there are only two discrete variables which have the unique features less than 25. These are cloud at 9 a.m., cloud at 9 p.m., which have very number of null values. So let's see what are the different null values and which column has the maximum of null values. Okay, so now as you can see, there are numerous amount of null values in this data set. Okay, so but this we can't tell how which, but from the number we can see that evaporation sunshine has many number of null values. But we will do that, we'll see them in percentage. Okay, it will make us more clear that which has and how much amount of null values. So what we will do, we'll just multiply it by 100 and divide it by the total length, which will give us the percentage. Now as you can see, evaporation sunshine is around 43 to 48% of null values, followed by cloud which has 40 to 38%. Then there are different other categories. Okay, so we have to handle all of these. So there are different methods to handle these null values according to their category. So what we will do, in order for our ease, we'll define a function which will tell us that, okay, which is what category. Okay, which variable is, whether it is a numerical variable, if numerical, whether it is continuous or discrete, or if it is a categorical variable. What I have done, I have defined a function, find variable type. I'll say variable is in discrete variable, print this format, that this is a numerical variable discrete in nature. If variable is in continuous variable, print numerical variable continuous in nature, and else print categorical variable. So now I'll just execute it. Then if I want to see which variable is what type, I'll just have to write its name. Okay, cloud 3 p.m. Now if I want to see, okay, wind direction 3 p.m., what is the type, I'll just see, okay, wind direction 3 p.m., it will tell me. Okay, so this is a categorical variable. So this, I did this in order to see it. Okay, we don't have any problem in understanding, okay, what type is what. So I'm just doing this. Okay, so this was our now the next thing with what we will do, we'll do random sample imputation for our for all the categorical, for all the variables which are having the maximum number of null values, right? And then we'll be doing the mean imputation. Okay, so we'll be doing this in our next section, in our next video. So let's proceed. Hello all, welcome to our next section of the project. In the previous sections, we saw that okay, how our data was distributed and what all the different categorical variables and numerical variables or the continuous variables. We also defined the function which will tell us that okay, which variable is what type. So now we also have seen that what are the different percentage of null values each variable was carrying. So now what we will do it, we'll be doing the random sample imputation. For what? For the variables which are having the maximum number of null values. That is the evaporation, sunshine, the cloud at 9 a.m. and cloud at 3 p.m. Okay, what I'll be doing, I'll be defining a function which says random sample imputation. In that, I'll be giving my data set, data frame, and my feature. Okay, so what I'll be doing, I'll define okay, df feature is my df feature. I'm giving the copying my data. Then I'll say this is a random sample in which all the samples which are drop and all the samples which are all the values which are having the null value, okay, all the null values please that get replaced by a sample, okay, or by a sample which are having the sample from my all the data, okay, the which what it will do, what this command will do, it will take a sample from my data, the evaporation or sunshine, any of the data which is passed, and it will replace that sample in that null value. Okay, so what is that is what this command is doing. Okay, and I am just then taking my index of that null value. Okay, so this is what this command is doing. This the random sample will be defined, and this will be then my defined, then my data frame will be updated with that null values. Okay, so I'll just simply write that function for all of this random sample imputation, df for cloud at 9 a.m., cloud at 3 p.m., evaporation and sunshine. I'll just define this function, then I'll run this function for all my this category, and then I'll say okay, so as you can see that all the null values in the evaporation part, sunshine part, cloud at 9 a.m. and cloud at p.m. are removed. These are all zero. What we have done is we have replaced all the null values from a particular sample, of the data set. This is one of the most effective technique to handle the machine values, right? So now let's proceed. uh, okay, so now let's proceed with other number of other next number of variables which are having less number of null values. Okay, the rest all depending, okay, rest all different continuous or numerical features. Then we'll do mean sample imputation, we'll do mean imputation. So now what we'll be doing in this, we'll be replacing all the null values with the mean. Okay, this we remember we are doing this for the continuous variable, this is not for the categorical variables, right? Because we cannot replace it with the categorical null values, we can not replace the categorical variable with the mean value, right? So this is for the all the numerical variables. What we are doing, we'll just copying the data set, then we are defining a mean, that is df feature dot mean. Okay, give me the mean of that variable, of that feature. Then we'll just replace fill na with mean. So what this will do, this will fill all the null values with the mean of that particular column. So I have defined all my different variables, okay, which are having the null value, which are numerical variables and having some null values. Okay, so now when I'll see, so as you can see, all my numeric continuous and discrete variables are filled with my null value, either the mean value or some sample in the data. Okay, so now the left value is the only thing left is my wind direction for 9 a.m., 9 p.m. in rain today, rain tomorrow. So this we are left with the categorical variables which we will be handling later in the label encoding part. I'll show you how we'll be handling them. So now what we'll do, we'll just plot a heat map. Okay, we'll just plot a heat map. So what heat map does is it is a visual representation of how our data is correlated. What I did is first I created a correlation map by just df.correlation command. Then I'll plot a figure and I'll just plotted a heat map. Okay, this is showing that okay, which feature is correlated to which based on the color scheme. Okay, if you'll see the color scheme, when if it's darkened, this is highly correlated, great, negatively highly correlated. Then if it is light, then it is highly positively correlated. Okay, so now the next thing is we'll do some analysis for our continuous variables. We'll just we'll just plot a distribution plot, okay, to see what how our continuous variables are distributed. Okay, so as you can see, minimum temperature is normally distributed, maximum temperature is normally distributed. This is our rainfall. We can see that the maximum number of rainfall is very less. Okay, as you can see, the count is very high for from 1 to 10 only. So, and the rainfall has not happened, then very few number of outliers are present. Evaporation is also present in 0 to 20 column. Then sunshine is distributed from all over. Then this is a just wind direction speed, which is also distributed quite normally, or not normally, but it is distributed all over, with the speed at 9 a.m., speed at 3 p.m. And humidity is also distributed from all over from 0 to 100. The majority part is between 40 to 80. Humidity is distributed quite normally. And this is also the pressure. As you can see, one of the outliers is very high, then rest of the data is normally distributed. Same with temperature. Okay, so this was an analysis for our continuous variable. We can also plot a box data to see the how our data is distributed in the value form. Okay, so we'll see that what is the maximum value, what are the different outliers. This is all shown by a box plot. Okay, so what we have done, we have plotted a box plot. We have plotted a box plot for all our continuous features. So as you can have a look, you can see that how your data is distributed, what are the null values, what are the maximum percentile, and all of that sort. Okay, so now this was all our data analysis part and handling our null values. Okay, so now in the next section we'll be doing the feature engineering, in which we'll be doing the one hot encoding, label encoding. We'll be standardizing our data, splitting our data to prepare for our model building. Hello all, welcome to our next section of the project. In this section, we'll be doing the feature engineering. Okay, so now the first part in our feature engineering comes is one hot encoding. So what we will be doing in one hot encoding, what we do is we usually get dummies. Okay, so we'll be performing one hot encoding in two parts. So first of all, let us have a look at our data first. Okay, so this is our data. Okay, so now most of the variables are continuous variables, are some of all are categorical variables, right? So the firstly we'll be seeing the rain tomorrow and rain today. So as you can see, we'll be only performing one hot encoding in these two parts, because what one hot encoding does, it creates a dummy. Okay, it will be creating a dummy. In that, for rain today, it will be creating two variables. For that, if the rain today value is true, rain today value is true for that particular variable, it will be assigning a 1 for it. And then rain tomorrow, then for the else, it will be assigning a 0. Okay, so what it will do, it will be basically mapping. If the value is true, then it will be assigning a 1. If the value is false, it will be assigning a false. So why are we doing one hot encoding for these two variables only? Why are we not doing for the other variables? Because of the fact that these all are having many number of categories. Okay, so what the one hot encoding will, that it will create many number of various columns. Okay, so which we cannot afford. So max it will create many number of columns. As you can see, the one only have 15 categories. Okay, so many number of categories will, many number of columns will be created, one only. So it can lead to curse of dimensionality. Okay, the model will get confused. Okay, so much number of variables are there. So we'll be doing the one hot encoding for these two only. Now when we'll see I'm also defining the command drop first is equals to true. So when these things will be created, the previous one will be dropped. Okay, so now let us see that how our data is created. Okay, so now rain today, it has created 0 for wherever it is not present, and the rain 1, it whenever it is the rain true today is true, then it has created the 1 for it. Okay, so now this is our df. So now we'll be doing the label encoding. Okay, label encoding, in which where the categories are more. So what, in order to do label encoding, we have to assign a value. Okay, so we can't just simply assign, okay, this one, this two, this. We'll be assigning them in the order of their weightage. Okay, so what we'll be doing, we'll be grouping our features on the basis of the rain tomorrow mean. Okay, which is having the greatest impact, we'll be giving it the highest priority. Okay, so I'm be doing as ascending is equals to false, and I'm just printing all the features. I'm grouping it with the by the rain tomorrow feature with its mean, and when I'm ascending false. So it is giving me a descending order, okay, which is having the highest number of impact is in the first. Okay, so now I'll just simply copy these lines and paste it here and give them the assign the order. Okay, so this is the having the highest priority because it is having the highest impact. Okay, so the same I have done for direction and give wind direction at 9 and wind direction at 3. I have just simply assigned them the value and I'm just simply mapping it in that particular column. df is equals to df wind just direction dot map this particular list. It will just simply get mapped, and now that these variables are converted into a numerical factor, we can simply replace their null values. We can simply replace their null values with any random value. Okay, we have just simply replaced the null values. Then if we'll see that what are the null values, there are no null values present. Okay, so our data set is completely clean. We have done all the null values imputation, and we have done the all the label encoding part. So now the one thing which is left is to check our location variable. Okay, all of our data is completely mapped and encoded. Okay, now the only thing which is left is a date and location. So first we'll handle the location part. For location part also we will be mapping with the variables. Okay, so now what we'll do, we'll just simply say use the same technique. We'll group by the location based on our dependent variable, and we'll sort it values. Okay, we'll sort the values and we'll store it in a different data set. Okay, as you can see, the what it has done in the first location, the Adelaide. Okay, let's suppose the first location is Adelaide. What it has done, it has sorted, it has given the value count. Okay, in this position the rain tomorrow value is false. Okay, and in this date the rain tomorrow value is true. It has done for all the locations. Okay, I'll just arrange them in a descending order. So okay, this all my values are sorted. First is the Portland, which is having the highest number of rain at tomorrow, rain today value, which is having the true. I have given the index 1. Okay, the index 1, which is this part. Okay, so it means that give me all those values in the descending order, which is having the true value in my rain tomorrow value. Okay, so this is all I've done. Then I'll just be getting the index all of these in that order. Okay, ascending is equal to first I have given the index, then I'll just simply copy it in that position. I'll just simply copy it in that position. There are the total number of 49 number of things. I'll just simply map from 1 to 49. I'll just simply map them. What I have done, I've simply mapped the location according to their weightage. Now if I now the next thing left is my date. I'll just simply split my date into date day and date day month by simply using pd.date time command. Now my data is completely distributed and completely fitted. Okay, so now as you can see, my location is mapped, my all the different variables are mapped, my new different variables are created, date month and date day. I don't need this date variable. Okay, so this is a simply count plot, how many number are rain tomorrow, and rain tomorrow are 0 and rain tomorrow is true. So as you can see, the rain tomorrow is true is less in number obviously. So now we'll just simply drop our date column, then we'll finally have a look at our data set. This is our complete data set. Okay, this is our complete data set. As you can see, the location is mapped, all the different things are scaled. Now what we have to do, the one thing we have to left is we have to split this data and scale our data so that it is completely available for a model building part. Before that, we'll just simply plot a QQ plot. QQ plot will help us see that okay, it is a plot, it is basically a combination of a histogram plot and a probability plot. So what it will do, it will help us see that okay, our data is normally distributed. If our data is falling in this line, okay, it is falling in that line, it means that our data is correctly normally distributed, and it is ready to go for a model building part. So you can also learn about QQ plot, see the documentation and see that okay, what QQ plot is and how it is used. So this is my data plot. As you can see, it is completely overlapping with the line. That means my data is good to go. I'll just simply split my data. The X is my independent variables. This is my independent variables, and this is my dependent 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 variable, the rain tomorrow and so while just simply scale my data, scale my independent variables, I'll just use standard scaler. You can also use min max scaler. you can see which performs better. I'll just simply scale and transform, and I'll again that convert it into my data frame. Okay, I'll just convert it into a data frame. This is my X column. Okay, so this is my X, this is my completely scaled independent features, and this is my Y, this is my dependent feature. I'll just simply split them into my train and test data. Okay, now my all my train data and test data is completely fitted. My data is completely ready for building my machine learning models. So in the next section we'll be building machine learning models with the help of different algorithms. Hello all, welcome to our next section of the project, that is the model building using machine learning algorithms. So the algorithms which we'll be using for this project are random forest classifier, Gaussian naive Bayes, k nearest classifier, and XGB, that is scholastic gradient boosting classifier. So now the first is the random forest classifier. So as you know, random forest classifier, I hope you are all familiar with it. Random forest classifier is a collection of decision trees. Basically, is an ensemble model which uses decision trees in the various number of decision trees to predict the output. So now there are two types of random forest. That one is the regressor, and another one is the classifier. So we'll be importing random forest classifier for this. We'll just define our model, and we'll just fit our model with the X train and Y train data. So now this random forest classifier may take a large amount of time, because what happens is the data, as you can see, your data is in lakhs. Okay, 1,54,000 around something. So random forest classifier might take some time, because it will be creating different decision trees based on the Gini impurity and another of that things. So by the time it gets fitted, let us discuss about the different other models. So the second model we'll be using is the Gaussian naive Bayes model. So now naive Bayes model is a model which works well when the data is continuous. Okay, and as we know, in our model most of our data is continuous. So and also Gaussian naive Bayes model assumes have a prediction that all of the data is Gaussian distributed or normally distributed. Now let's see that our random forest classifier is fitted. We didn't hypertune our model, because at last we have to make our model with the PyCaret, that's the auto machine learning technique. I am just explaining you how you can build your models like this. You can also do the hypertuning part with these models, but I am not doing that for a sort. So now we have predicted my X test. Now let's see the confusion matrix, accuracy score, and classification report. As you can see, my confusion matrix is this which stands for true negative, true positive, true negative, false positive. As you can see, relative to the data set, a true false positive and false negative are quite less, and a true positive and true negative are very true negative and true positive are quite good. Okay, and the accuracy is around 85%. Okay, 85.3%. If I'll just multiply it by 100, it will give me in figure, it in decimal figure, 85.37%. Okay, and this is the classification report. This is the precision, recall, f1 score, average, macro average, weighted average. These are all the parameters which are given in a classification report. I can also plot a ROC curve. Okay, my ROC curve, if I'll plot, okay, this is my ROC curve. As you can see, the area under curve is 0.88. Okay, as you know, for a ROC curve, the maximum the area under the curve, better it is for that classifier. So this was our random forest classifier, which had an accuracy of 85%. Now we'll be using the Gaussian naive Bayes classifier. I'll just fit it and do the same things. I'll define my model, I fit my model, predict my model. So now, as you can see, this model has an accuracy around 80%. Okay, and these are the confusion metrics and the ROC curve we will be plotting. Okay, so this is our this is a ROC curve which has a slightly less area than the naive Bayes, which has 0.82. This has an area AUC of 0.88. So now Gaussian naive Bayes classifier is basically used when we are using the NLP, right? Which is where the data is continuous, or the NLP part. The Gaussian naive Bayes is quite good, works quite good on that. Okay. So now the next is our k nearest neighbor classifier. I hope you are all familiar with the k nearest neighbor classifier. Basically, what it does, it creates clusters on the basis of this neighbors. It creates information. So now when I'm applying the k nearest neighbor, there is a function in that we have to define the neighbors. Okay, I've defined the neighbors here three, but what the main thing is, you can write a function, which you can tell, you can see that okay, how many neighbors you can select. You can define a function in which you can define an error rate. Then you can define a array and a list like that, take neighbor from 0 to 10, and then you'll fit your model with all those neighbors, and you'll then see that which model has the least error rate in it, then you'll select that number of neighbors. I have already done it, I have not demonstrated here, but I have demonstrated in other projects. You can see there. So now this, I have defined the neighbor is there 3. Now this model is getting defined or fitted with the leaf size 30. Metric is Minkowski number of neighbor 3, number of n jobs none, metric parameter none. These are the basic parameters. Okay, basic parameters which are being used by in the k nearest neighbor part. Now what I am doing, it is predicting my X test. Okay, it might take some time. If it is obvious, it will be taking some time because our data is quite large. Okay, so the by the time it gets fit, it predicts our result. Let's see our next classifier, which is our XG boost classifier, gradient boosting classifier. As you know, boosting is an ensemble technique we are all familiar about. Okay, boosting is an ensemble technique, and base this okay, boosting is an ensemble technique. As you know, our data is predicted. Okay, this model gave an accuracy of sorry, 82%. Okay, 82%. And let's see our AUC score. What is our AUC score? Okay, so as you can see, the precision is 0.87, recall is 0.92, F1 score is quite good. So overall, our both all the three models are relatively better, but the random forest being the best, which having a 85% accuracy and highest number of AUC curve, AUC area. So now it will take some time. It will again predict the ROC car. So KNN is taking some time. So moving on. This is our XG boost classifier, which works on boosting techniques. If you want to see how a boosting model works, you can have a look at the documentation. You have a look at the documentation, see how it works. What I'll do, I'll just simply import XG boost. Now, what can happen is when you import it, it might say that no module named XG boost is present. If that is the case, then you first have to install XG boost in your system. You can see the documentation how to install XG boost. When you'll just define the model classifier. I'll just fit and tray. I'll fit my model, then I'll predict, and I'll see the same accuracy and the score. Then at last, as you can see, I have already done. Okay, so I know that which model performed the best. So the XG boost classifier is my best performing model. Okay, so this is my AUC curve. As you can see, among the three right now, KNN is the least performing model. Okay, then it is an accuracy of around 82. Oh, sorry, it has an AUC score of 0.79, which is the least of all. Now, when we'll see about the XG boost classifier, let's see how does it perform. A model get fitted, it will take a minute or two again. Now, in order to save time, what you can do is you can split your data. Okay, you can take some samples of your data, you can take some samples and then fit your data. Okay, so now my model is predicted. As you can see, this has an accuracy around 84%. Okay, and AUC score of 0.87. As you know, I have taken the XGB classifier. You can also take random forest classifier, as it also perform the same. So in order to pickle our file, we are using the XGBoost classifier. Pickling a file is necessary to deploy our model, right? You can I'll be just pickling my file, and I'll do the same thing. I'll open this file. I've already executed it, that's why I'm not doing it. I'll just open a file which names rain xgb new model. And what I'll do, this is a write base command. So what this command will do, okay, pickle.dump, which means that dump this model into this file. Okay, so my model will be completed. So now what happens is, this is my file ready for deployment, which I'll be telling you in the next section. But before that, we'll be seeing that how we can build all this model with the help of automated machine learning, that is the PyCaret library, that I'll be discussing you in the next video. Hello all, welcome to our next section of the project, that is the automated machine learning section. So now in this section, we'll be seeing how we can use automated machine learning in order to escape all that hustle which we did before of model building and all other things. So we'll be using the PyCaret library. Okay, so PyCaret is an open source low code machine learning library in Python that allows you to go from preparing your data to deploying your model within minutes in your choice of notebook environment. Okay, so let's see, I'll just show you that what PyCaret is. You can visit your website. This is a pretty important or interesting website. Okay, PyCaret is a pretty interesting website. As you can see, this is their home, and everything is written. Okay, every information is given in their website. As you can see, getting started, this is the PyCaret guide, how you can install PyCaret. Then these are the functions, the initialize, in which getting data, setting up environment, model training, comparing models, create. I'll be telling you what are the things I have used here in the X section. But first of all, let us install PyCaret. Okay, so now if you are installing PyCaret, if you are installing PyCaret in your local environment, you can simply install it in your Google Jupyter or Google Colab using the command pip install PyCaret with an exclamation mark. So now I have already installed the PyCaret, that is why it is showing requirement already satisfied and all of that sort. So now what you have to do, you have to import your libraries. So now what I am doing, from PyCaret.classification import star. So now what this will do, as I know, as I completely know that this is a classification problem. Okay, so I am importing all my libraries which are present in the PyCaret classification, all my libraries into my library, into my environment. Okay, as you can see, initialize, set a modeling, comparing models, create model. See, this is an option like this: a compare model, create model, tune model. Okay, so this is the create model part. In that, as you can see, regression and anomaly detection, this is the classification, the one we have to use. Okay, so what we'll do, we'll just import this is what it has. See, importing modules and initializing setup. We have already imported the data, and then we'll set up our model. Okay, we'll set up with this command, the model gets set up. Okay, what you have to do, you just have to define your model setup. You have to give the data. I have given the data df. Okay, I have given the data df. Then I'll set, okay, target is my rain tomorrow. Okay, rain tomorrow, you have to define it. Okay, what is your target? On that basis, it will automatically select all the models. You just have to select type here. Why? Because it is asking, okay, whatever the numeric data type it is created, it is right or not. You just type y and create, and that's enter. Then it will automatically set up your models. It will automatically set up your model. Now, as you know, these are all the operations which are being performed. Okay, wherever it is not performed, it is done false, because it has not combining rare levels, multi-collinearity threshold, removing perfect collinearity, it is done true. Then all the other things, everything it is done. Okay, so now what we can do in the next model, when we'll see, we have created, we have set up a data. Now what we can do, we can compare models. Okay, the first thing we can do, we can compare models. What compare models will do, as you can see, this is the first step we recommend in the workflow of any supervised experiment. What this will do, this will compare all the models. Okay, I have done that, but I am not doing that because it took me around 25 minutes to compare all the models, because obviously the data is too large, around 1 lakh rows. So what you can do, you can either split your data into small parts and then compare your models from. But from that, I got my model. The first leaderboard my model had was the light GBM model. Okay, so which was the light GBM model, which is given here in here. When I'll go to create model part, when I'll go to create model part, as you can see, these are all the models which are present in this classification. So when I see the light GBM, okay, light gradient boosting, see, okay, this is my model. Okay, these are the ID which is used by the PyCaret, and these are their names. So when what I'll say light GBM, I'll define a model. I'll say create model, and I'll provide that ID. Okay, I'll provide that ID. Then what it will do, it will start creating that model for me. Okay, it will start creating that model for me. As you can see, it is saying fitting 10 folds. That means that it is taking 10 folds for the data. It is be folding, it will be taking 10 times for that data. It will be giving me accuracy, AUC, recall, precision, and all of that. So what I can do after that, my model will be created. Okay, then I'll just predict my results. So as you can see, this is my accuracy. This is my accuracy for every fold. My mean accuracy is 85. Okay, 85.56, and my AOC is 88.1. As you can see, what we did in the previous section, by using those four models, we compare all the models. We didn't even hyper tune it. Okay, so now what PyCaret did for us, PyCaret predict hyper tuned all our model and given this. Now what we can do, we can also tune it a more, okay, by the option. As you can see, it is written tune model. Okay, if you want, you can tune your model. Okay, these are the instructions given how you can tune your model. You just have to write tune model and give the model name. Okay, the model you have defined, then it will automatically train you. You can train according to your iteration, according to your optimizer. Okay, there are numerous amounts of things you can perform using PyCaret library. I have demonstrated you how to use that. Then now finally I'll just predict model. I'll use that model which I have created, and I'll give the data x test in the previous one which I have already tested. Okay, I'll just print my predictive predictions. So as you can see, this is my predictions. Okay, when you'll just shift to the last, as you can see, this is my label. This is my label. Okay, this is my label, which means that if it is 1, then it means okay, it will rain tomorrow, and if it is 0, it will not rain tomorrow. Okay, this is my score, which means that okay, how much is the accuracy for that score, which it has compared with the test train data. Okay, so this was all of the things which it has taken. Okay, this was all of the thing. This was a brief introduction about the PyCaret library. These are numerous amounts of things which you can see in the PyCaret. Okay, like there are different tutorials for classification, regression, cluster, and anomaly detection. It even have NLP in it, mining, association rule mining. If I'll go into classification, it will have different tutorials that okay, how you can perform the different models, classification, regression, clustering, anomaly detection. Okay, I think there are numerous amounts of things. Okay, you can see various number of things. You can see and compare all of the different models. So this was a brief introduction of how you can use automated machine learning library, PyCaret in particular, to do all your machine learning part. Okay, I will be providing you the notebook and all. You can practice it. Now in the next section we will see how we can deploy our model. We have pickled our XGBoost model. Okay, you can pickle any of the model you like. I have selected here my XGBoost model. Okay, I have pickled my XGBoost and I have my file ready with me. What you have to do, you just have to download your file from the it should be present here also. It must be present here. It will be present here. Okay, when you will download it, I have already downloaded it. You just have to download this file from your Google Drive. Then the next thing I'll show you how we can deploy your model with the help of Flask API. Hello all, welcome to our last section of this project, which is the deploying section. So in this section, I'll be telling you how you can deploy your model with the help of Flask API. So now first of all, what you have to do, you have to download your pickle file which you have created from your model and make a new folder. Okay, make a new folder and paste it here. Now in that folder, create a new file. I am using the PyCharm ID. You can use any of the ID for making your deployment code. What you have to do, you just have to open a code, open an ID, new window, and then you have to write this code. Okay, don't get too much confused by this code. This is a very simple code which I have written. What you have to do, these are the basic libraries which we have to import from Flask. Import Flask render template, URL for request, JSONify. Okay, then we'll import pandas, numpy, datetime, pickle. These are all for required for our next data processing part. So now what we'll do, we'll just load our model. Okay, we'll just load model dot pickle dot load or model. This will load our model. Okay, then define our Flask. Okay, we'll just define our Flask and we'll say okay, my templates are stored in my template folder. Okay, what you have to do, you have to create your template. Okay, these are I have created my templates. I'll show you my templates. So this is my template. The first one is my index template. So I have provided you this created by basic using HTML code. If you want to go to the page source, this is my HTML code. What I have done, I have just simply used the basic CSS styling, and I have just simply created all the different buttons. Okay, these all the different buttons and all the different things, the location and all the code is given to you. Okay, I have provided all the code, and this is a very simple code. You just have to write a few lines to give all the options. Okay, because it has many number of options. You just have to write this code. This is my index code which will open right before. Then the next is my after rainy. Okay, this is not rainy, and this is my the next is my after sunny code. Okay, this is my after sunny code. Okay, if the prediction comes out, okay, it is a rainy, then this will template is open. If it is a sunny, then this template will open. Okay, so now in the next section, Now what you have to do, that what you have to do, you just have to define your folder. Okay, template folder is in template. Okay, then I'll say okay, app root, this is a common basic method. App root method is my get method. Okay, I'm getting my URL. Then what I'll do, I'll say define home, just render my template. Render template means get the template. Okay, when I'll click on my URL, it will get that template, it will get my index template. Then the page it will open that I showed you. Then I'll say predict. Then I am defining a different method, predict. There was a different predict option na. So now what I'll say, if the predict method is given, the predict method is given, then what I'll say, take all those values. Okay, what I am doing, I am taking all my values, I'm taking all my values from the user which I've inputted and storing them here. Okay, the first is the date method. I'm taking the user which will input, I'll take the date method and convert it into the day and month separately. Then I'll take the min temperature, max temperature, and store it here with the help of the request form. Okay, then all of the things. Now in the next thing, which is the location. Okay, as you remember, in my data set my location was like that. I have mapped my location on the basis of 1 2 3. Okay, so the same thing I have to do here also, because then only my data will predict, right? So what I'll do, I'll just simply say if location is equals to Portland, I'll give that number. Then similarly I'll be doing for all the 49 things. I have not done, but I've done this only to make you understand. Okay, I've done this for only 16 locations, so I'll just be doing that. You can write for all the 47 locations, it will be a very big code. The same thing I have done for all the categorical variables. Wind direction 9, that is if the wind direction user inputs is nmw, then it is 0. Then if nw, that is 1. That is the same method I have mapped, which I have used in my machine learning model, right? As you can see, in my machine learning model, if I have also I have used nw for 1, nw for nz for 0. As you can see, Mortland for 1, Cairns for 2, Walpole for 3. And then in that direction also you can see nnw 0, nw1, wnw2. The same thing I have done here also. Okay, same thing I have done. So what I'll do, I have done all for that. In the rain today also, if the rain today is yes, then click on, then it is 1. If it is no, then click on 0. Then what I am doing, I am storing all those values in a list, and then I am just saying model.predict input list. I am giving the data and predict that. Then I am storing my prediction in output model. Then I am saying if output is equals to 0, then render my template this. If output is equals to 0, that means there will be no rain. Okay, it output is 0, that means there will be no rain. That means what I'll be doing, I'll just render my template. I'll say okay, the after get me the after sunny HTML. Then if it is the output is 1, then give me the after rainy HTML. And I'm saying okay, finally run my app, and debug is equals to true. Debug is equals to true will tell me basically what all the errors are. So when I'll run this app, make sure you have this app file in that, your pickle file in that, and your template file in that. Then when I'll run this, it will run in this way and provide you a URL. Okay, it will run on your server when you will click here. Okay, as you can see, my model is complete. My model is deployed. Okay, but this is deployed in my local environment. I can select my dates. Okay, the date is today. I'll say my temperature, pressure, and all the different things. Okay, I can see all the things. Okay, I can render, and when I see, I can select all the location which I have given. I'll see wind directions. I can select all of these things. Did it rain today? Yes, no, and all the things I can enter. When I'll enter it, and then I'll say I'll click on predict. It will predict my option. But what happens is this is given on my local environment. Okay, so now in the what I can do, if I want to deploy it in a more global environment, I want a URL. So I'll be needing the Heroku platform service for that. Okay, I'll be needing the Heroku platform service. For that, what you have to do, you have to upload all of these files into your GitHub folder. Make a GitHub account, upload these files in a repository, upload these files in a sorry, upload these files in a repository, and then you have to deploy your model using the Heroku. I'll be showing you how you can do that in the next section. Hello all, welcome to our final section of the project, that is deploying our model using Heroku. Now the first thing you have to do, you have to log into your GitHub account and you have to create a new repository, right? I am also creating a new repository. I'll just say a name, okay, that is the rain prediction. Okay, and my new, and then I'll say this as public. I'll write a readme file, then I'll create a repository. Okay, I have created this repository. Then what I'll do, I'll add all my files. Okay, I'll upload my files. What I'll do, I'll upload my files. I'll choose choose your files, I'll say, then I have these files present. Okay, I'll just upload all of these. I'll just commit my changes once they are get uploaded. Now what all files are present in this, I'll be showing you in a moment what all files are required for this. But as you can see, this is my proc file. Okay, this is my proc file. You just have to I'll be providing you this file. You just have to upload this file in your GitHub account. This is required for deployment. This is my your py file, this is your pickle file, and this is your requirements file. Okay, these all are the libraries which are required for it. Okay, these are all the libraries which are required. So now as you can see, we have already this is my app file, this is my all of the things. This is my also I have not uploaded the template folder. Okay, I'll just upload the template folder also. Okay, what I do, I'll just drag it. It is uploading all the folders. Okay, my now template folder is also uploaded. So now I have to go to my Heroku. I'll type Heroku platform. I'll just go here. You have to create an account. Okay, log into your account, sign up and create an account. It is totally free. It is totally free. Now you just have to log into your account, whichever your account you have. Just log in here. Okay, I'll do it later. Then this window will open. This sort of window will open. Okay. So now Heroku is a cloud-based platform. These are all the apps which I have made earlier. So now what I have to do, I have to create new app, right? I'll just click on new, create new app. I'll say it's an app name. Let's just say it rain prediction. It is saying not available. It is, let's just say rain prediction. It is not available. Rain prediction new. Okay, rain prediction news available. Select the region to United States only. Then click on clip app, create app. Okay, now after creating app, you have to import your data, right? That's why I made you to create a GitHub account. So you can connect to your GitHub account and you can directly upload your data into Heroku platform. You will just say select a repository. You just connect your repository. Then you'll say repo name. My repo name was rain prediction. I'll just search for it. Okay, this is my repository. I'll just connect to it. Okay, I'll just connect to it. Now we have to deploy our model. Okay, there are two ways. First is the automatic deploy, and second is the manual deploy. This it will be deploying through your branch only. So I'll just simply click on deploy branch. So now what it will do, it will take all the requirements which was necessary. It will be installing all the different packages and it will be telling you, okay, what are the different requirements. Okay, so these are all the necessary files which are required. One is the proc file, one is the requirement, and this all are all the other things. Okay, it is just downloading all the things, and it will in the last it will be providing you a URL. Okay, it will be providing you a URL which will be the same, which will be a global URL. You just have to paste it. When you click on it, your this prediction app will open. Okay, this will be your prediction app. It will provide you a new URL. It will take some time. Okay, you just try it. You can just do it. You just have to import all the things which I have provided. Import all the things which I have provided to you in your GitHub account and just deploy it by the method which I have shown you. Okay. So this is how you can deploy a model with the help of Flask API and Heroku. You can also edit this page. Okay. You can create new stylings if you have a good knowledge of HTML. I have a basic knowledge of HTML. That's why I've used all of this. I've taken a single background and all of this thing. You can change these. You can change the text, any of the things you like. Okay. So now what this was a brief, and this was the introduction of basically a tutorial on how you can deploy your model using Flask API and Heroku. I have provided you with all the codes, all the different libraries, and I have provided you the data also, this notebook also, and the all the files required for the development. Okay, you can try it on your own, try it and deploy this model, make new model with the help of just taking reference on of this. I'm sure you will try to make new things and learn from it. Thank you.